Okay, we're going to be looking at a difference of squares and how to factor that. Now the first thing that's important is to recognize when is it a difference of squares. So I'll just give you an example here. We recognize that this is a difference of squares because of two things. Importantly is that it is subtraction, so that it is in fact a difference of squares. And the other thing is that there are two terms. We have the x squared and we have the minus 4. So those are the two terms that we are going to be factoring. Now, in order to factor a difference of squares, so we want to try to factor x squared minus 4, we have to try to identify two things that are being squared. In order to be a difference of squares, it has to be two things that are squared that you are subtracting. In this case, we are squaring the x, and in order to get the 4, we can think of that as 2 squared. So now that we have identified it is a difference, and it is a difference of things that are squared, we can now go to the factored form. The factored form in a difference of squares always takes the form of two binomials that are multiplied together, one with plus and one with minus. And you can switch the order on that, it doesn't matter. And so what you do is you say, well, the thing that I'm squaring here is the x, so that goes in the first position. And over here I'm squaring the 2, so I'm going to put in the 2. So we believe that this is our factored answer. In order to check your work, this is easily done by simply expanding out the brackets. So suppose I wondered, is this correct? So what I'm going to do is I'm going to take the x plus 2 and the x minus 2, and I'm going to expand out the brackets and see if I get the x squared minus 4, which I started with. So I'm going to go x times x, which gives me x squared, x times negative 2, which is negative 2x. Then I'm going to move on to the positive 2 times the x, which is positive 2x. And lastly, positive 2 times negative 2, which is negative 4. And when I cancel out these two middle terms, I am left with x squared minus 4, which is exactly what I was supposed to have. So our answer does work. So that is the difference of squares factoring. So what I'm going to do now is run through a few examples just to make sure that we are clear with this process. And then I think we're good. We're going to factor p squared minus 1. Again, in order for this to be a difference of squares, there's got to be something squared minus something squared. So in order to get p squared, we would have to put a p there. So p is being squared. And to get 1, we would want 1 squared. So the factored version of this is going to involve a plus and a minus. And we have the p times the p to give us p squared, and 1 times 1 to give us the 1. Okay, next example. The next example is factoring a little bit more complicated, x to the 6th minus a quarter. So again, I have to identify, is it something squared minus something squared? And I think it would be. Whoops. So something squared minus something else squared, and I would want x cubed, because if you think x cubed times x cubed does give you x to the 6th. And here I have a fraction, but that's no problem. All I have to do is remember that it is 1/2 times 1/2 that gives us 1/4. Well, now that I've recognized what it is that is being squared, I'm ready to put it into the factored form. X cubed times x cubed, and 1/2 times 1/2. And we're on to my last example, and that is factoring the following. We are going to factor 3x to the 4 minus 243. With this last example, there's a very important point that you should never forget when factoring. If these terms have a greatest common factor, you should always factor that out before continuing. Because right now, it looks like it could be a difference of squares, but it isn't. That's because we have this 3 and the x to the 4, and then this 243. Well, they're not nice square numbers. So the trick is take out a greatest common factor first. And that greatest common factor is 3. And that would leave me with 3 times x to the 4 and 3 times negative 81. So that's my first step done. My greatest common factor is taken out. Then I take a little look at what I have remaining, and I do see that this could be factored as a difference of squares. What I have to do is think to myself, well, what is it that I am squaring in each of these cases here? Well, this would have to be x squared that's being squared, and to get 81, I would have to have a 9 that's being squared. So that guides me to this factored version now, difference of squares. I would need x squared times x squared, and to get the 9 squared, well, I want 9 times 9. Now, we're not finished with this, because over here, we have what is still a factorable expression. This is still a difference of squares. So I'm going to leave the first part of this alone, but I am going to factor out the second part as a difference of squares. Here, to get the x squared, I would have x times x, and here to get that minus 9, I need a 3 times a 3. So this is our final completely factored answer. So I hope that helps you understand how to do a difference of squares.